Hey, good morning everyone. Welcome back again. Hi Navdeep, Shakeen. Yeah, a very good morning to all of you. Yeah. So we checked, yeah. We are live now. Everything is clearly visible and audible. So regarding the topic of our today's discussion, till now in the mechanics part of physics, we have been talking about the kinematics only, and the other fundamentals associated or related to this kinematics unit, which are not only restricted to kinematics, but they will keep coming in different topics for us. All right. So basically in this bridge course, we are strengthening our fundamentals, and definitely we are looking for the alternative approaches for all the crucial type of problems, that if a problem is difficult, there will be a conventional method, there will be a method with which that problem is generally supposed to do, which all of your competitors are also going to opt in the exam. But the advantage of attending these sessions will be slowly you will be able to develop your alternative methods, alternative approaches towards these crucial problems. All right. So yeah, offline classes start from which date? Very soon we'll announce the date of offline batches also. We are also waiting for the NEET results and further celebrations, expecting a great result this time. Even the paper was tough, but yes, the students who were already they have taken the training and the proper formal coaching from the team. You may realize that even at the last moment, even in the last few days, whatever crucial problems we were doing, they were directly or indirectly as in this exam. And same I want for everyone now, that we have already started our journey for NEET 2026. Every day must count. Every single effort which you are putting in, attending the lectures, hopefully revising on everyday basis, doing some 1-2 bits of the problems which we are allotting to you, all these things, all these efforts will be counted. All right. So can we start now? Let us start our discussion with kinematics, another part, that is circular motion. Till now, we were talking about the translational motion. The body is moving in a straight line. Either it's a unidirectional, I mean straight line without turning, or it may be a straight line with the turning, or it may be motion in 2D, motion in a plane. But motion in a plane also, we discussed the projectile motion. We discussed that if you have a ball in your hand and if you throw it horizontally or vertically or at an angle, then the horizontal projectile, vertical projectile is motion under gravity, and the fundamentals of oblique or angular projectile motion. Today's topic of discussion is circular motion. Another example, I would say, of motion in a plane. So if a body is moving in a circular path, circular trajectory, then definitely you can say that its motion is in a plane. Okay, that plane may be XY plane, XZ plane, YZ plane, or maybe any random plane. All right. So for the sake of our simplicity, we will understand the fundamentals, the way I was telling you that in projectile motion, we preferably want to break the entire motion along two perpendicular axes. One is x-axis, one is y-axis generally. What is the advantage of breaking the motion along two perpendicular axes? That those two axes will be independent of each other. Similarly, in circular motion, you will realize that we are changing the axis, but every time we are talking about two perpendicular direction. One is the radial direction, means along the radius, and another one will be the tangential direction. One will be the radial direction and one will be the tangential direction. That is going to be the entire story of our discussion. Okay. In a normal projectile motion, x-axis and y-axis. In case of motion on inclined plane, we will always take along the inclined and perpendicular to the inclined. I repeat, in case of horizontal projectile or oblique projectile motion, we will consider x-axis and y-axis. In case of inclined plane problems, we will consider along the inclined and perpendicular to the inclined. Similarly, in circular motion problems and topics, we will consider one is the radial direction and one is the tangential direction. All right. So keeping this in mind, let us start. Yeah. So now, concept of circular motion. So basically, first of all, we will understand when a body moves in a circular path, what are the parameters we need to focus on? Physical quantities, what are their values, what is their variation, how they changes in magnitude, changes in direction, like what are the things, basic things associated with circular motion. So let us consider a case. Let us imagine that there is a m mass object and moving in this circular track about a point O as a center. Point O as a center, and this is the, like, with respect to center, this is the position vector. With respect to center, this is the position vector r vector. And it is moving in this direction. Suppose it is moving in this direction. Assume that it is moving in this direction with maybe some angular velocity omega. Omega is angular velocity. Okay. So where will be the velocity? The velocity will always be directed tangentially. This is my v vector. V vector is also called as v instantaneous vector or v tangential vector, because instantaneous velocity will always be tangentially. Basically what I am telling is, if the particle is moving about this point having center O and moving about this point, then position vector always keeps on changing. Suppose I'm drawing three situations. The particle might be here, and let us assume that as of now, particle is moving in this direction only. Okay, particle is moving in this direction, and suppose this is the position 1 of the particle. This is position 1, this is position 2, and this is position 3. Position 1, position 2, position 3. So you will say this is R1 vector, this is R2 vector, and this is R3 vector. R1 vector, R2 vector, R3 vector. Since the particle is moving in a circle, then definitely this distance is going to be the radius. So I would say the magnitude of R1 vector, magnitude of R2 vector, and magnitude of R3 vector are going to be same, and that should be called as radius. Mind it, guys, I am not saying the vectors are same. Vectors are different because their directions are different. Okay, this direction, directions are different. I'm just listing the properties of circular motion, and you may expect, see, circular motion, definitely there will be one problem at least in NEET 2026. That one problem may be coming from kinematics of circular motion, dynamics of circular motion, which involves the discussion of centripetal and centrifugal force, or maybe the conservation of energy application in circular motion that will involve the vertical circular motion majorly. All right. So circular motion we have to consider in three phases for us. Phase number 1, which we are taking today, that is the kinematics and understanding the parameters or physical quantities and variation of physical quantities in circular motion. Number 2, the dynamics, the forces involved, the cause of circular motion, centripetal and centrifugal forces. Number 3, the conservation of energy in circular motion, which will majorly involve vertical circular motion, motion of a particle over the smooth or rough surface of a hemispherical bowl, spherical bowl. All are the general cases which you may expect in the exam. All right. So out of all this stuff, today we are going to discuss only the first thing, that is the kinematics part. So what we have understood, that position vector will be having the same magnitude, that will be called as the radius, and r cap direction is variable. So overall, if someone is asking you position vector, that is also variable. Magnitude is constant. Magnitude is constant, but direction is definitely varying. Magnitude is constant and direction is varying. Okay, so the entire vector will surely vary. Now, in the same case, if I try to understand the velocity vector, so because of this clockwise assumed sense of rotation, we have assumed that the particle is moving in clockwise sense. So velocity is always tangential. So there will be this velocity, there will be this velocity v1 vector, here tangentially v2 vector, here tangentially v3 vector. And I hope you understand it precisely that tangent and radius are to be perpendicular to each other. So this angle is 90 degrees. This angle 90 degrees. This angle 90 degrees. All right. So velocity and position vector are always going to be perpendicular to each other. So I will say here magnitude of velocity vector may be constant or variable. May be constant or variable. That will depend on the condition or type of circular motion. We will understand that very soon. But direction v cap surely varies. Direction v cap surely varies for sure. You can see direction will keep on varying. Magnitude may or speed of rotation may be same, may be different, but direction will surely keep on changing. If direction surely keeps on changing, so definitely v vector is also going to be variable. V vector is also going to be variable. All right. So their position vector is variable because of variation in direction. Here velocity vector is variable because of sure variation in direction, but there may be a variation in magnitude also, because we don't know whether the speed of moving in a circular path is constant or variable. That may be constant, may be variable. Both are the situations in our NEET syllabus, as well as very soon, today only, we will talk about all types of cases. All right. Now, if velocity is variable, then according to the basic logic of kinematics, who is responsible to vary the velocity? Obviously, acceleration is responsible to vary the velocity. So if velocity is variable, there must be some acceleration. There must be some acceleration for sure. All right. So if I talk about circular motion, so circular motion, how do we define the circle? How do we define the shaped circle? We define the shaped circle as design which is obtained after joining all the points, which are equidistant from a single point. That equal distance is called radius, and that single point is called center of the circle, which means I'll define the circular motion in such a way like particle moves in such a way that its distance from a fixed point is always a constant. Why we are not defining the circular motion on the basis of velocity, sir, or on the basis of position vector? Because you see, these things are like completely as a vector, these physical quantities are variable. So I'm just defining the circular motion in terms of the physical conditions involved, not in terms of variation of quantity, but in terms of constraints involved. That condition is particle must be moving in such a way that its separation from a fixed point is always constant. This constant distance is called radius, and this fixed point is called center of the circle. So particle moves in such a way that its distance from a fixed point is always a constant. This fixed point is called center of the circle. Here I am denoting the center by O. And this fixed distance, fixed or constant separation from that point is called radius of the circle. Is called radius r of the circle. All right. If I talk about the Cartesian form, Cartesian form, then Cartesian form means the way you understand that linear equation in two variables, always represent a straight line. Similarly, what will be the xy condition or xy relation for a particle, or equation of trajectory or for a particle? You know, since last 2-3 days we have been talking about this, that if you want to understand that what is the design of the path in which particle is traveling, the design of the path in which the particle is traveling will be given by equation of trajectory. So here we say Cartesian form for equation of trajectory. What is that? X minus alpha whole square plus y minus beta whole square is equal to r square. Here r is radius basically. R is radius, and center is given by alpha comma beta. I'll give you two examples to understand it in a better way. Example number 1, which we are generally going to use. Example number 1, suppose it is x square plus y square is equal to 16, right? This can be written as x minus 0 ka whole square plus y minus 0 ka whole square is equal to 4 square. In that case, center is basically origin 0, 0. Center is basically origin 0, 0, and radius is going to be 4 units. Because we can just compare it directly with the equation of the circle. All right. Example 2. I will say x square plus y square or y square minus 4y plus 4 equals to 8. Like this. You have got this equation. X square plus y square minus 4y plus 4 equals to 8. So can you write it as x square plus y minus 2 whole square, and that is equal to 8. More appropriately, you will say x minus 0 whole square plus y minus 2 whole square is equal to 2 root 2 whole square. All right, please have a look. What I did is, there was an equation given to me. I tried to convert this equation into the standard form. When I converted it into the standard form, the advantage of that is I can easily comment about the center as well as the radius. So what will be the center over here? The center over here is 0, 2. The center over here is 0, 2. You know, it should be in minus x minus alpha, y minus beta. So we will ignore the minus sign, and the center is 0, 2 here. And radius is going to be 2 root 2 units. I hope that is understood by us. Just reduce the size a bit. Yeah, that's the story. All right. So the thing is, first of all, what we have understood till now is how to define the circular motion. Circular motion is basically defined as a special type of motion in which a particle moves in such a way that with time, its distance from a fixed point always remains fixed, constant. That constant distance is called the radius of the circle, and that fixed point is called the center of the circle. Okay. During its motion in a circular track, the position vector's magnitude, which is basically the radius, that will remain constant, but its direction will keep on changing. As a result, overall position vector keeps on changing. Okay, and the time rate of change of this position vector will be basically velocity vector. So we will say velocity vector is always tangentially. You can see here that velocity vector, radius vector, this position vector is radial vector. This velocity vector is tangential always. So its magnitude means speed of moving in a circular path may or may not be same. But like it may be constant, speed may be constant or may be variable. Instantaneous speed may be constant, may be variable, but the direction will surely keep on changing. And who varies the velocity? Acceleration. So can I say in circular motion, since the velocity vector must be variable, acceleration must be there. I repeat, in circular motion, velocity vector must be varying. So who has to be present to vary the velocity vector? Acceleration vector, which means there is no circular motion possible without acceleration. Acceleration has to be there because velocity vector must be changing. Magnitude may be constant or same, but the direction tangentially will keep on changing at each and every instant. Is that clear? All right, perfectly fine. Now, few other things. How to, like, if you know that the equation given to you is a circle, if you know the equation given to you is the equation of a circle, then by converting it into the standard form, you can answer what is the center and what is the radius. You can answer what is the center and what is the radius if the equation is known to you that it is a circle. But sir, what if we have to identify that whether it represents the equation of a circle or not? For example, if you know in your childhood, first of all, examine, like in books, whatever you have studied, it was given to you that it is a straight line. And now you are supposed to find out that what is the slope, what is the y-intercept, this, that. But how to identify that the given equation is a straight line equation? You know, you say that linear equation in two variables maximum, linear degree, it should be linear equation in two variables maximum is going to represent a straight line. We know the identification point. Similarly, if the equation is given to you and it is told to you that it is the equation of circle, then by doing this, you can identify center and radius. But if it is not given to you that it is a circle, then how to identify? So I will say identification. Identification here. Let me move all this here a bit. Okay. I'll just write the identification here. Identification of circular trajectory or equation of a circle. It should be both powers, x square and y square. Straight line, linear equation in two variable. Both powers are single and single. Here it is both x and y have power 2 or degree 2. Both x and y have degree 2. Equal coefficients of x square and y square. Equal coefficients of x square and y square, and no term containing xy should be there. No term containing xy together. No term containing xy together should be there. I hope you understood. What did I say? I said that just like you identify that linear equation in two variables always represent a straight line. Similarly, if the coefficients are equal and a plus sign in between, you can say it is going to represent a circle. It is going to represent a circle over here. Okay, and these are the other mathematical conditions. For a while, you can keep it in mind. When the right time comes, I'll take some more examples. I'll give you some random equations of trajectory very soon, not today. Very soon, I'll give you some random equations and conditions, and then I will ask you, tell me that how the particle is moving. Particle is going to move in a straight line or a parabola or a circle or an ellipse or an hyperbolic path. Like I'm going to ask you that. Understood? So for everything, for every geometrical path, slowly, today we are not going to understand everything, but for every geometrical path like circle, conic sections, straight lines, all these which are common for our NEET syllabus, slowly we will keep learning their conditions. Is that clear? So I hope the definition of circular path, the conditions involved, as well as the examples, how to identify the circular path. And if the circular path is identified, then in that case, how to get the information of circle and radius. Everything is there in front of you. Take a minute, review everything carefully. Let me know in the live chat session that if you have any doubt. Is these okay? Are these classes for 11th? Yes, these classes are valid for 11th, for 12th aspirants, as well as, obviously for these are targeting to our NEET exam, NEET 2026. So if you are an 11th class aspirant, then also I am using some of the vector notations, but majorly I am explaining the entire theory so that you can feel how the circular motion works and what are the physical quantities involved in the discussion of circular motion. Definitely, even if you are an 11th class student, everything you can understand. Concept is clear? Okay, let's move on. So we have started today with circular motion kinematics. Our today's target is only till circular motion kinematics. Kinematics, no dynamics, no centripetal, centrifugal force. Centripetal acceleration we will discuss, but no centripetal or centrifugal forces. Okay, and no energy consideration, no kinetic energy, potential energy, loss in energy and all. Okay, now the next discussion is types of acceleration in circular motion. Types of acceleration in circular motion. I'll start with a very small note here that the basic differentiation logic, we know velocity vector or any vector can be represented by its magnitude and its direction. Any vector can be represented by its magnitude as well as in its direction. If I differentiate with respect to time, so I'll do something mathematically. Don't focus much on the mathematics involved. But focus on the logic. Okay, try to see. So differentiate with respect to time. If I differentiate it, this is dv vector by dt, and on the right hand side there are two physical quantities. If there are two physical quantities, we are going to apply product rule of differentiation. What is the product rule of differentiation? Differentiation of any one, second one as it is, plus differentiation of the second one, first one as it is. So I'll write differentiation of the first one, dv magnitude by dt, all right, this second one as it is, plus first one as it is, and the differentiation of the second one, dv by dt, all right. Now I will understand all these terms individually. So I'm saying dv vector by dt. dv vector by dt means that physical quantity, it is showing that physical quantity which is responsible for the variation of entire velocity vector with time. Or you can also say in common terms, complete velocity variation with respect to time. This will give you net acceleration vector. Time rate of change of net velocity with is called acceleration, net acceleration vector. Here the first term, see this differentiation is by product rule, all right. Here the first term is signifying the time rate of change of magnitude, but the direction is not changing. Means it is that type of acceleration, you know now that velocity's direction is tangential. So it is that type of acceleration whose direction is also tangential, but its responsibility is to vary the magnitude. I repeat, the v cap is tangential. Okay, v cap means unit vector, direction. So v cap means the direction of velocity, that is tangential direction. So the first term is denoting that type of acceleration whose direction is tangential, but whose responsibility is to vary the magnitude. So this acceleration is tangential acceleration. Tangential acceleration. All right. Remember, tangential accelerations, direction is tangential. That's why the name is tangential. But its responsibility is to vary the magnitude. And here it is an acceleration. It is an acceleration whose responsibility is to vary the direction. It is an acceleration whose responsibility is to vary the cap. Vary the cap. Cap means direction, unit vector. So here this acceleration is centripetal acceleration. Centripetal acceleration, or the other names are radial acceleration, or other name is normal acceleration. Why it is radial acceleration? Why it is centripetal acceleration? Centripetal means center seeking. towards the center, which has the love towards the center. So centripetal acceleration means always directed, always, obviously this is always directed tangentially. This is always directed towards the center, towards the center, or along the radius, along the radius, okay, or normal, perpendicular. Perpendicular, normal means perpendicular. It is always directed perpendicular to the direction of motion. What do you mean by direction of motion, sir? Direction of motion means that is velocity vector, that is centripetal acceleration cap, centripetal or centripetal acceleration vector will be always perpendicular to net velocity or instantaneous velocity vector. What did I say? The name centripetal means it has a love towards the center. It is center seeking. So this acceleration whose name is centripetal or radial or normal. Why its name is centripetal? Because it is always directed towards the center, center seeking. Why its name is radial also? Because it is always along the radius. Why its name is normal also? Because it is always normal or perpendicular to the direction of motion, instantaneous direction of motion, or you can say instantaneous velocity. But these three are the names. What is the responsibility? The responsibility is changing the direction. And what is the responsibility here? The responsibility of tangential acceleration is changing the magnitude, Now what you need to understand is that when the body, here I told you, when the body is moving in a circular path, its speed may be constant, may be variable. Its speed may be constant, may be variable. So tangential acceleration, whose responsibility is to change the speed. Tangential acceleration, whose responsibility is to change the speed, it may or may not be there. Because if tangential acceleration is there, this speed will vary. If tangential acceleration is not there, its speed will not vary. So what about the speed? Should it vary? We can't say. So basically in a circular path, in general, when the body is moving in a circular trajectory, its speed may be fixed, may be variable. Similarly, so what I can say here is that this tangential acceleration may be zero or non-zero. May be zero or non-zero. When the tangential acceleration is zero, the speed will not vary. It has the responsible for, let me write it for you. Responsible to change the speed. Responsible to change the speed. All right. So if it is available, if it is present in the situation, it will keep on changing the speed. If it is not available in the situation, it will not change the speed. So speed may be constant, may be variable. Tangential acceleration may be present, may be absent. What is the formula for tangential acceleration? Direction, though we have already seen, it is tangential. Its magnitude is going to be equal to this dv by dt, d mod v by dt. I'll just write it in terms of speed, dv by dt. See, I'm not writing the vector over here. I'm writing speed, dv by dt, rate of change of speed, or you can say v dv by ds. V dv by ds. Basic kinematics, dv by dt can also be written as v dv by dx, or that can also be written as r alpha, where alpha is angular acceleration, product of radius and angular acceleration gives you tangential acceleration. Remember, in terms of language also, words also, product of radius and angular acceleration gives you tangential acceleration. All right. Now let me comment about this. If I talk about the net acceleration, it is responsible. So how do we get the net acceleration? As you can see, one is along the radius, one is along the tangent. So its magnitude AT or A net magnitude will be given by, so A net vector is given by AT vector plus AC vector. Okay, if you add these two, so you will get the net vector. Since these two are perpendicular to each other, independent to each other, A net magnitude will be given by under root of AC square plus AT square. Tangential acceleration may or may not be there. Tangential acceleration may or may not be there, but centripetal should be for sure there, because the responsibility of centripetal is to change the direction, here. All right. If I talk about the angle made with velocity vector, angle made with V vector or AC vector, AT vector. Chalo, let's talk about the angle after, like on the next slide. Let's talk about the angle in detail in the next slide. So I am here talking about this. It is always directed towards the center or along the radius or this. It is responsible to change the direction, of velocity vector. Hence, it is always there. It must be present. Tangential acceleration may or may not be there because speed may or may not be changing, but the direction keeps on changing at every instant, no? And whose responsibility is to change the direction? Centripetal acceleration or radial or normal acceleration's responsibility is to change the direction. Since the direction keeps on changing, this type of acceleration must be present, and it is always directed like this. Its magnitude, so direction is clear to us. Magnitude formula of tangential is there. Similarly here, direction is clear to us towards the radius, along the radius or towards the center. Its magnitude will be given by, AC magnitude is given by V square by R or omega square R. V square by R or omega square R. Instantaneous speed ka square by R or omega instantaneous square R. Alright. So the magnitude of tangential is clear and its direction is tangential. Responsibility is changing the speed. The magnitude of centripetal is clear. Its direction is towards the center or along the radius. And its responsibility is clear, that is to change the direction. And if magnitude is also changing, direction is also changing, then definitely you have to talk about the net acceleration. Vectorially, it is the sum of these two, but magnitude wise, you can directly do under root of AC square plus AT square, as AC and AT are perpendicular to each other. As AC vector is perpendicular to AT vector, naturally, this is the way you take the magnitude. This is the way you take the magnitude of two perpendicular vectors. I hope we are clear with this. All right. So today we have understood the circular motion. What is the definition? What is the way in which a particle can move in a circular path? Then we have seen its equation, just like serving as equation of trajectory, how to identify the center and how to identify the radius and how to identify that whether really it's a circular motion. While moving in a circular motion, what happens to the position vector? What happens to the velocity vector? We have seen here. And what happens to the acceleration vector, or how many types of acceleration are there? That is also in front of you. Take a minute, review everything carefully. Just see whatever is written on the board. Let me know in the live chat session that if you have any doubts, and if it is clear, give me a thumbs up so that I can take you towards the problems. Have a look. Any type of doubt you have, you can just post in the chat session. I'll try to answer it. Understanding now, we have covered every minor thing involved, or every minor thing related to the kinematics, position vector, velocity vector, acceleration vector, what else happening with time, everything related to the circular motion, that is in front of you, except angular kinematics. Angular kinematics, like angular velocity and angular acceleration, I have used here, but angular kinematics I haven't talked about. So some other day maybe, but not today. Today it's not required. Any other doubt, dear? All right. Chaliye, so let me take you towards few problems, and all the discussion and topics are always never ending. So we will keep talking about more and more of them. So this is the first thing, a very important model for, like, I'll give you some fundamental problems, a lot of them, a lot of PYQs and expected problems we will do today. But out of all the problems we are going to deal today, two I'm going to highlight. Two are very important for us. One is right now in front of you, right? First problem I have taken very important. And these are the A, B, C, D, but if you read the question carefully, these are not four options. You don't have to choose one from them. These are four parts of the question. So this we are going to deal subjectively. And in the final NEET exam, any one question, any one part may come for you. All right. So what is the question? A particle moves on a circle of radius r with the centripetal acceleration as a function of time as this. AC value is given to you. AC value is k square RT square. K square RT square. This value is given to us. Okay. Where k is a positive constant, find the following quantities as a function of time. In terms of time, you have to find out these four quantities. The speed of the particle, tangential acceleration of the particle, resultant or net acceleration of the particle, and angle made by resultant with the tangential acceleration. Interestingly, there can be few more parts. How the kinetic energy varies, what is the work done, what is the power delivered, everything will be there. So these are the four parts. We will discuss these four and then I may add 2 or 3 more. But if in any problem going forward, examiner is asking you, tell me the acceleration. If examiner asks you the centripetal acceleration, then find only centripetal. If the examiner is asking you, tell me tangential, tell tangential. But if examiner is asking that, tell me the acceleration, then you are bound to tell the net acceleration. Okay, you are bound to tell the net acceleration. So how you are going to tell that? So first of all, I would like to analyze the equation given to us. That equation is AC, given it is AC is equal to k square RT square. K square RT square. This implies AC can be written as V square by R. So V square by R is k square RT square. This implies V square is equal to k square R square T square. है ना? Centripetal acceleration magnitude, just now I told you, that is either V square by R or omega square R. But they are asking you the speed. That's why I'm writing it this way. This implies V will be equal to KRT. V will be equal to KRT. Okay, taking square root both sides, V will be equal to KRT. This is part A for us. This is part A. Okay. Now they are asking the tangential acceleration of the particle. Tangential acceleration AT will be equal to dV by dt. dV by dt. So you are going to differentiate this expression. If you are going to differentiate this expression, that is going to be KR, because T's derivative with respect to T is 1. So this is our second part, B part, what they have asked. Remember, in final NEET exam, they might be asking you any one thing. That one thing may be out of these four, or that may be the remaining 2-3 stories related to the same question. And this question, this model particularly is going to be very, very important. So now, and make sure here, since I'm putting so many efforts in selecting the problems for you, telling you the predictable problems for the final NEET 2026 exam, make sure here you definitely share these sessions, the bridge course sessions, to your friends, to your known other aspirants. And if you are in a long term, or your sibling, your brother or sister is also in 11th class, these sessions of bridge course are also going to be fruitful for them. Okay, so these are very beneficial for 11th, 12th or any long-term students preparing for the NEET exam. These are also beneficial for the JEE exam, because looking at the pattern of the NEET 2025, we are definitely inducing some flavor of JEE, putting some essence of JEE type models for these NEET based sessions also. So if you are a physics student of 11th, 12th and long term, and if you are preparing for either NEET or JEE, then definitely these sessions are going to be very beneficial, and let the others learn also. Your minor effort of sharing these sessions to others will let them also learn, and sitting back at home, they can also make a better use of their time. So let us learn together. spreading education is one of the, most auspicious thing we can do. So the tangential acceleration of the particle that is in front of you, the resultant acceleration. I told you if they ask just acceleration, then you have to by default find resultant. Here to itself they said that finding the resultant acceleration. So the resultant acceleration a net magnitude, that will be under root of AC square plus AT square. So under root of AC square is K square RT square and its whole square, and AT is basically KR. AT is basically KR, its square. So definitely I can take single K, single R outside, and inside under root of this term will be 1 for sure. Okay. And it was K to the power 4, out of which K square I preferably tried to take out. So out of K to the power 4, if I take K square out, it will be remaining K square. And R square, I have already taken single R outside with a square, and here it is T to the power 4, like that. So just keep checking the calculations. So this way you can get the net acceleration also. This is in fact the answer for us for the C part. And what others? They are asking the angle made by the resultant with the tangential direction. The angle made by the resultant with the tangential direction. So for the D part, I'm going to do that separately. D part, see, this is the circular path. Here is the particle moving with this tangential velocity or instantaneous velocity vector. And here is the point O, and it is the position vector. All right. So let me mention both the accelerations. Here tangential acceleration is positive. Positive means it is supporting the speed, supporting the velocity vector, I would say. So this is the tangential acceleration vector. This is the towards the center, centripetal acceleration vector. Somewhere there resultant here, by completing the parallelogram law, you will be getting the net acceleration vector. Tangential acceleration vector, centripetal acceleration vector. The resultant of these two is net acceleration vector. Now they are asking angle made by the resultant with tangential direction. You are interested in this angle phi. So here phi will be equal to tan inverse. See, you remember the basic vector rule I have taught? With whichever axis the angle is made, that component must be coming in the denominator. I repeat, with whichever axis the angle is made, that component must be coming in the denominator. So phi is equal to tan inverse, with which axis you are making the angle? Tangential axis. So AT must be coming in the denominator and AC must be coming in the numerator. So AT is basically KR. We have done in point B. AC was given in the question as K square R T square. So single power K R, single power KR can be cancelled. KR is cancelled, and you have got here K, and you have got here is T square. So that will be tan inverse. Single power K will be remaining, and T square will be remaining. So this KT square must be dimensionless, because all the angle and tan and tan inverse, whatever is the input, it is dimensionless. Its square is also going to be dimensionless. K square T to the power 4. This must be dimensionless. Then only you can add or subtract it to a number. I'm talking about principle of homogeneity here, because if the question contains 4 options, your objective or elimination approach may be based on your principle of homogeneity or dimensional analysis, I would say. All right. I hope the 4 parts in the question are clear for us, right? They have given centripetal acceleration, we have talked about speed, then we have talked about tangential acceleration, then we have talked about acceleration by default, or you can say net acceleration or resultant acceleration. After resultant acceleration, if they ask the angle with tangential, then tangential component must be coming in the denominator. If they have asked the angle with the radial, then radial component must be coming in the denominator. So this expression will be reciprocal of it, right? AT will come in the numerator and AC will come in the denominator. The basic rule is with whichever axis you make the angle, that component must be coming in the denominator. And right now on this slide, there are 4 different questions and their answers in front of you. All right. Not only that, I would say that suppose here they are asking you the angular speed. If they are asking you the angular speed, then angular speed omega, E part I am mentioning, angular speed omega is equal to V by R. If you do V by R, so that value is going to be KT. V by R is K into T. Is that clear? V by R is KT. Suppose they ask you the alpha value, alpha, F part, angular acceleration. So, I told you AT, tangential acceleration, is R alpha. So, alpha will be equal to AT by R. So, if you do this AT by R, see the value of K you got as angular acceleration. So, AT is R alpha. So, R into K will be basically AT. So, that's what I told, that there are two more parts, angular speed and angular acceleration, which can be asked to you. Okay. And in near future, we will also discuss few more things. EF are done. G. If they are asking you the kinetic energy, that kinetic energy is half mv square. So that half mv square is half m k square r square t square. Because the speed is basically kRt. And if they are asking you the h part, power, that is equal to dke by dt. Power is dke by dt. So if you are going to differentiate that, this half will stay as it is, m will stay as it is, k square r square will stay as it is, t square derivative with respect to t is 2t here. So what you can see is 2 and 2 will get cancelled out, and hence the final answer is mk square r square t. mk square r square t. This is the expression of power. Because a very important unit of ours in NEET syllabus is work energy power. Here it is. And if they are asked way 2, this is the h part, or way 2, our way of doing that could have been, so sir, which acceleration can deliver the power, or which force can deliver the power? Can centripetal force deliver the power? No, because centripetal force job is to change the direction. So who changes the speed of the revolving particle? Tangential is responsible to change the speed. So the type of force or acceleration which is responsible to change the speed, which is responsible to change the kinetic energy, that is only capable of delivering the power. So power can be written as F vector dot V vector. Here I am writing this F vector must be tangential. Because centripetal's job, listen to my words very, very carefully. Centripetal's acceleration or centripetal force job is to change the direction. Changing the direction does not involve any energy delivery or any power. Change of direction does not involve any energy delivery or any power. Okay. The change of speed or the change of magnitude of velocity vector, the change of speed, magnitude of velocity, or change of kinetic energy involves the power delivery. If kinetic energy keeps on increasing, power delivered to the system is positive. If kinetic energy of the system decreases, power is extracted from the system. And if kinetic energy or speed is constant, there is no power. Okay. So here you will say P is equal to F dot V. So in that case, it must be tangential acceleration mat into instantaneous velocity into cos 0 degrees. Why cos 0 degrees, sir? Because velocity is also tangential and the tangential acceleration is also tangential. So both the vectors are basically parallel, and hence the angle between them is 0 degrees. So see, it is m, tangential acceleration you have already derived, kr. Speed you have already got, krt, and cos 0 is plus 1. And hence the final answer is m k square r square t. M k square r square t. You see, this value and this value, these are going to be same. Is that clear? All right. So examiner is giving you AC is equal to k square r t square. Depending upon that, We have talked about the 4 different parts what examiner has asked: speed, tangential acceleration, net acceleration, as well as the angle made by the net acceleration with the tangential acceleration or net velocity. 4 parts we have talked from my side: angular speed, angular acceleration, kinetic energy, as well as the power delivery. I hope everything, all the 8 parts, 4 from the examiner's side, 4 from the my side. I hope all the 8 parts are clear to you. Just have a look on the board. Let me know in the live chat session, is everything clear to you? If everything is clear, thumbs up. And if there is any doubt, just post it over there. We'll have a discussion. So it is very important model here, very important model for NEET, very important for NEET 2026. In this bridge course, even we are in the starting phase, there will be no surprise that some questions may be directly picked for NEET 2026 from this bridge course. So make sure you do it wholeheartedly and make sure you revise it thoroughly in the last hour of the day just before you sleep. Rule of revision is very much important. Slowly, you will understand huge benefits of that. Any doubt? Any doubt, anyone dear? No doubt? Okay, very nice. So let's move ahead now. So this was one of the problems. There are few more problems I have brought for you, few basic problems. But since you didn't have any doubt now and you are able to understand the good level problem, so let me take you towards, this one. This is also, so I told you that out of 9-10 problems, predictable problems which I have brought for you today, there are 1-2 problems which are very important. This is also very important problem for NEET 2026. So I would suggest you first of all to take a look, read the problem carefully. You can tell me in the comment section the approach this time. Okay, read the problem, go through it thoroughly, and then I'm looking at the live chat section right now. I'm expecting your opinion. What should be the steps to deal the problem? Then I will explain it to you in detail. I hope that's clearly visible on the screen. Is that clear on the screen? Yeah. Read that clearly. Try to understand what examiner is asking. And now I am expecting your opinion here. Be frank. No doubt is a silly doubt. If it is a doubt, it is always an important doubt. No opinion is a silly opinion. I really appreciate, I really encourage every opinion of yours. You just put the opinion. If there will be a doubt or slight modification in your thought, I'll do that. Kiran is saying net acceleration. Very nice. Why Kiran is saying net acceleration? See, examiner is asking you find the acceleration. They are not mentioning centripetal acceleration or tangential acceleration. So if they are not mentioning, then by default, which acceleration you are supposed to find? Net acceleration. Absolutely correct, Kiran. And apart from that, in order to get the net acceleration, you must be having the knowledge of both the accelerations. AC also, AT also, then only you can do under root of AC square plus AT square, and hence you can get a net. All right. Very nice. Any other opinion, guys? So first logic is very much appreciated, like very nice. They're asking you net acceleration. Then what else? They are giving V is equal to alpha root S. Last time, if you notice, we were dealing in terms of time. We had this model which was given in terms of time, in terms of T. Okay. But now we are having in terms of S. But no worries. If tangential acceleration is dV by dt, it is also v dv by ds. If tangential acceleration is dv by dt, it is also v dv by ds. So I'll write here, given the v value as alpha root s. alpha root s. It is not in terms of time, but it is in terms of s. So from here, what you can say, they are asking you acceleration. They are asking you acceleration, find the acceleration. So they must be asking you net acceleration or resultant acceleration. If they are not mentioning which acceleration, then they must be asking both of them. All right. So v is equal to alpha root s, centripetal acceleration or normal acceleration or radial acceleration. Centripetal acceleration or normal acceleration or radial acceleration. Its formula is v square by r. Its formula is v square by r. So if it is v square by r, it is alpha root s whole square by r. So that will be equal to alpha square s by r. Step number 1. So if they ask centripetal acceleration, that's your answer. Very simple. If they ask tangential acceleration, then tangential acceleration is dv by dt or v dv by ds. v dv by ds. So which formula you are going to use? We have used dv by dt if velocity. We would have used dv by dt if velocity is given as a function of time. And we can use v dv by ds if velocity is given as a function of s. So here you can see dv by dt we can't use because there is no time here. But v dv by ds we can use because there is s there. Hope you are understanding. Both the formula are equally valid, but which one to use, that will depend on in functions of what, in terms of what our velocity is given. If velocity is given in terms of time, use the first version. If velocity is given in terms of s, use the second version. So you are going to use the second version. So in the second version, v dv by ds, 1v is as it is, alpha root s. Okay. Then it is d by ds of alpha root s. Okay. 1v is as it is, alpha root s. Another v is differentiation, d by ds of alpha root s. So this alpha being a constant coefficient, being a numerical, being a coefficient here, I can take it out. I can take it out of the differentiation and I can multiply here. So what I am getting is alpha square root s, and it is d by ds of root s. For your convenience, I am writing the differentiation term in the square bracket. So this alpha also came out, alpha square root s and d by ds of root s. We know d by dx of root x is 1 by 2 root x. I hope everyone knows d by dx of root x is 1 by 2 root x. d by dx of root x is equal to 1 by 2 root x. We know this. Okay. If you didn't know it, remember it from now. It's a common differentiation in physics. So d by ds of root s is 1 by 2 root s. So tangential acceleration here, that is alpha square root s, curved brackets. And for your convenience, in this square bracket, d by ds of root s is 1 by 2 root s. You see root s got cancelled and your answer is alpha square by 2. Root s is cancelled and your answer is alpha square by 2. Remember, this is not the final answer. This is tangential acceleration. Centripetal acceleration is directly obtained. Tangential acceleration is obtained by v dv by ds because it was given as a function of s. But examiner is asking you net or resultant acceleration. So your net acceleration is given by under root of ac square plus at square. So that is under root of ac square means alpha square s by r whole square plus alpha square by 2 whole square, and it is under root of ac square plus at square. What I can take outside is, I think, alpha square as per the 4 options. So under root of, what you will be getting here is s square by r square plus 1 by 4. S square by r square plus 1 by 2 square means 1 by 4. So this is your final answer. Select from the options. Alpha square 1 by 4 plus s square by r square. I think option B. Yes. Yes, Teja. Option B. Yes, Chandana. Option B. Very nice. Manideep is saying integration of V to find out A and net acceleration. No. V is differentiated to find out A. See, Manideep, you are having a basic doubt. I'm writing it for you. That if you have position vector, I'm writing here, okay? I'm writing here. If you have position vector, especially for Manideep, I'm writing it. If you have position vector and you want velocity vector, or you have velocity vector and you want acceleration vector, okay? And if you have acceleration vector, you need to go to velocity and velocity to r, then you must know that here, basically position vector to velocity, you need differentiation. Velocity vector to acceleration, you need differentiation. Acceleration vector to velocity, you need integration. And here also you need integration. Okay, basic kinematics part. So what I'm saying is, if velocity vector is given and acceleration is required, then only you will differentiate. If acceleration is given and reverse was required, then only you will integrate. So in this question, velocity was given. Velocity was given. What is given here? Velocity. See, this velocity is given and you need acceleration. So from velocity, if you need acceleration, then definitely you will involve differentiation. Differentiation will be involved. Okay, but involved only for tangential. Only for tangential acceleration, not for centripetal. Not for centripetal, not for net, only for tangential. I hope everything is clear. Any other doubt? Any other doubt which is going in your head? See, I could see that there was a student, Manideep, asked something I emphasize. Similarly, I am telling everyone, if you have any other doubt, feel frank, be frank. Just post your doubt there. Whatever is relevant, I will definitely try to help you out. Slowly only you will try, you will be able to think what I think, the way I think for the problems. And trust me, the day you will be able to map up my thought towards the problems, you know, whenever you see a problem and you start feeling that what sir would have thought in it, what sir would have done in that, that day is going to be your achievement, and then only together we can succeed in the final exam. All right, so just try to learn the different ways of thought, different methodologies, and keep telling. Is everything clear now? Yes, very nice. So this was the second very important model which I have brought for you today, and this was the previous one. This was the previous one in which we have discussed 8 different parts, 4 given by the examiner, 4 given by me during the discussion. I think everything is clear to you now. Let us discuss few more. This is also a good example. See, in the given figure, A equals to 15 meter per second square. They are giving acceleration. So if they are asking the acceleration or they are giving the acceleration, then by default it should be which acceleration? Net acceleration or resultant acceleration. Yes. The total acceleration it represents, and moving in the clockwise sense, see the diagram is also given to you. If radius is 2.5 meter at a given instant, the speed of the particle is the speed of the particle. See, so I will say that is the acceleration A. Here what can I do is, I'll take its component. This will be A cos 30 degrees and this will be A sine 30 degrees. See, I've done the vector resolution. If A vector is making an angle theta with the radius, then radial direction will carry A cos 30 degrees component and tangential direction will carry A sin theta component. Easy. Here, this A cos 30 degrees is basically serving as centripetal acceleration, and this A sin 30 degrees is basically serving as tangential acceleration magnitude, and that is centripetal acceleration magnitude. Okay, tangential acceleration magnitude and centripetal acceleration magnitude. What they are asking? They are asking the speed of the particle. They are asking here speed of the particle. Okay. So if they are asking you speed, see how I'll do it here. I'll say here centripetal acceleration is basically v square by r, or that is omega square r, and that is equal to A cos 30 degrees, A net cos 30 degrees. A net cos 30 degrees. All right. This V square, I'll use the first formula. I'll use the first formula because they are interested in the value of speed. They are not asking angular speed. If they ask angular speed, I'll use the second version. So if they are asking you the speed, I'll use the first version. The radius is given to us as 2.5 and that is equal to net acceleration. The net acceleration value is given to you as 15 meter per second square. The net acceleration here is 15 meter per second square. So that 15 and cos 30 degrees, cos 30 is root 3 by 2. Root 3 by 2 value is approximately 0.866. So you just have to multiply that. Yeah? That's not a big issue. So V will be equal to under root of 2.5 into 15 into root 3 by 2. As I said, it is 0.866. So it's square root. So NEET will not check your calculation. Don't calculate. Okay. What I'm telling you to do is approximate. NEET is not checking your calculation. You can roughly do some approximation and you can get your final answer. Let us see how you can do that. So it's 2.5. So you will say 15 into 2.5 if I will do, or 2.5 can be written as 5 by 2. Okay. So 15 into 5 is 75. 2 will cancel this 0.866 or take it as 0.9. Okay. Or 0.866 by 2 if you do, you will get 0.433. So here we got 75 into 0.433. So 75 into 4, anyways, what is that? 75 into 4 is 300. 75 into 2 is 150. 75 into 4 is 300. 75 into 0.4 is 30 naturally, but it was 0.433. So it should be slightly greater than 30. So, and its root, oh my God, its root also you have to take. So I would say that 5 square is 25, 6 square is 36. So near about the range of 30, the square root will be in between 5 and 6. In between 5 and 6, its answer must be 5.7. Do you want me to repeat it? I'll repeat it for you. How do I approximate? You can check your approximation. So what I'll do is, I'll try to write it as under root of 5 by 2, 15, 0.866. So this is approximately under root of 15 into 5, 75 into 0.433. Okay, approximately under root of 75 into 4 is 300. 75 into 0.4 is 30. So approximately 30. It would be approximately slightly more only. Slightly more only, more than 30. Okay. So now I'm saying under root of 25 is basically 5. Under root of 36 is basically 6. So root 30 approx will lie in between the two. Root 30 will lie in between the two. Approximation, I can do the standard calculation also, but for the NEET exam, it will be a waste of time. Examiner is not expecting exact calculation. They are only expecting approximation. So let's be a bit more comfortable in taking the square roots here. So definitely root 30 lies in between them. So for sure, the square root of that will lie in between 5 and 6. So that's why I could directly choose it without doing any direct calculation. If you want, you can use your calculators and then go ahead. You can check. Like that. So there will be many more problems. Every time I will emphasize on this thing that if a question is coming, if a physics question is coming in the NEET exam, they will only check your physics, not memorizing the formula of physics, not mathematical calculations, but more logical aptitude. All right. I hope you liked today's session and you have understood various things in circular motion. There are more problems and there are more and more concepts, but we can keep talking about those concepts and in different phases, those concepts and questions in different phases. Phase 1 was kinematics, which we discussed today. Not tomorrow, but later on, very soon, we will talk about the phase 2 of circular motion, dynamics, centripetal and centrifugal force. And then at last, we will be talking about the conservation of energy in vertical circular motion. All right. Till then, take care, have a small break. Then you are going to resume with your chemistry session with Anirudh sir, and all the best. And definitely, I hope again that you are going to revise each and every fundamental which we are discussing before you sleep tonight. All the best, guys. Take care. Bye bye.